So the first thing we're going to do is actually what's called Rolle's theorem. So for each of these theorems that we're going to talk about today, there are certain conditions that have to be true. And you will have to remember the conditions and what the theorem says. So when it comes to a test or quiz, I'll say use mean value theorem to show this, or use Rolle's theorem. And so you will have to first check the conditions to make sure that those are true. So Rolle's theorem has three conditions. If your function is continuous on a closed interval, so continuous means no breaks in the graph. Things that we have looked at when we were talking about continuity, if you have a piecewise function, it may not be continuous. If we had breaks in the graph, looking at a picture, if there's a visible break in the graph. If you have a rational function, so something, an x on the bottom, where you would have a vertical asymptote, those are situations where it would not be continuous. Polynomials, we know, are always going to be continuous. Second thing, it's differentiable on the open interval. So differentiable means the derivative exists. Open interval means it doesn't have to have a derivative at the endpoints. It's okay if those derivatives are undefined, but inside that interval it has to be everywhere. The things that would make it not differentiable, obviously the breaks in the graph. Also think about the absolute value. When you have that sharp corner, the derivative doesn't exist there. Third condition is the two endpoints have to be equal. If all of those are true, then that means somewhere in that interval the derivative is 0. To understand this, I just put some pictures on here. Okay, if I have a continuous function, so no breaks, derivative exists, so no corners, and the endpoints are equal. You could have like a horizontal line, in which case every single point in that interval, the derivative would be 0. We could have something like this. It went up and came back down. So we see right here, we have a horizontal tangent line. Derivative is 0. You could have more than one. Okay, if you're going to start and end at the same point, you could change directions multiple times along the way. But no matter how I draw that, there is a place where the derivative is 0. Okay. I left a blank slide. I just kind of showed you visually. Do you guys believe me visually, or do you want me to prove it like a mathematical proof? Are you guys interested in seeing the proof? You believe me? Okay. You don't take much convincing, huh? Alright. So here's a question. If the position of a moving object at two different times is equal, what does Rolle's theorem tell us? Okay, so you have some kind of moving object, okay? Like, let's say one of my kids' remote control cars. If it starts here and at some point it is back here, what does that tell us?
It stops moving.
Okay, it had to have stopped moving at some point. So, at some instant, the velocity, which is the same as the derivative, was 0. It had to change direction at some point. Let's do an example using equations. I'm just so excited because you can see the board so much better now. I'm not struggling. I really thought my eyesight was going because I could never see my board anymore. Okay, suppose this is our function. Find a number c that satisfies the conclusion of Rolle's theorem. Okay, in order for this to work, Rolle's theorem requires it be continuous, differentiable, and the endpoints have to be the same. So we need to check those conditions. Keep in mind, a 1/2 is like a square root. A 3/2 is like a square root cubed. What are the only numbers you can't put into a square root? Negatives. If I'm on the interval 0 to 1, do I have to worry about that? No. So that means it is continuous and differentiable. It's defined everywhere, there's no breaks in the graph. I am not going to require you to do much justification. We have done in previous sections, like way back in chapter 2, we talked about what it meant to be continuous and differentiable. So I'm not going to require you to give me a justification for why it is, but you do have to state that it is, so that I know you've recognized it. Then, those are the first two conditions. The third condition, we have to see if the endpoints are the same. So if I plug in a 0, I get 0 minus 0, which is 0. If I plug in a 1, I get 1 minus 1, which is 0. So the endpoints are equal, so we can do Rolle's theorem. Then what does Rolle's theorem tell us? What has to be true? What's 0? The velocity, or the derivative. So now we're going to find this derivative and set it equal to 0. And we should get some number between 0 and 1. Okay, that's like a 1 over 2 as x. Let's say I add this term over. Cross multiply. So 6x equals 2. And x is 1/3. If you got multiple answers, you would be only taking the one that fell between 0 and 1. Okay, so it is possible that I might get an answer that doesn't fall in the interval, but Rolle's theorem told me there was at least one in the interval that would work. Okay. Is that one alright? Take a second and look at this one, see what you think.
You can't take the square root of a negative number.
So a 2/3 power, that means the cube root of x squared. So 3/2 we wouldn't have been able to do. Can you do the cube root of a negative? We can, so the function's defined everywhere. That part is okay. Let's do the derivative. So I get 1 minus 2/3. X to the negative 1/3. That's like saying 1 minus 2 over 3 times the cube root of x. When is that undefined?
X is 0.
This does not exist if x is 0. So is it differentiable everywhere between negative 1 and 1? can't use Rolle's theorem. If you're ever not sure if something is differentiable, an easy way is to do the derivative and see if it's ever undefined. You know, in the previous example, when I did my derivative, I maybe should have done that before I told you it was differentiable. What's the only number we couldn't plug in here? 0. But that was okay because 0 was the endpoint, and it doesn't have to be differentiable at the endpoints, just the interval between them. Here, because 0 was in my interval, it wouldn't work. Okay. Let's do another one. If f of x here is a polynomial, we've said before polynomials are always continuous and always differentiable. So if you want to check your conditions, f of x is a polynomial, so it's continuous on the closed interval -2 to 2. By the same reasoning, it would be differentiable as well. I mean, it'd be differentiable everywhere. We only have to have it differentiable in the open interval. It's also okay if you just want to say it's a polynomial, so continuous and differentiable. You just have to acknowledge those pieces for me. The third condition is that the endpoints are equal. So if I do f of -2, -8, I get a -6 if you plug in a +2. I get a -6, so those endpoints are the same. That means Rolle's theorem works. So now, what does Rolle's theorem tell us?
Sum and velocity equals 0.
So we do the derivative and set it equal to 0. Okay, I can try to factor this with Box method, but I don't think it's going to work. Have to multiply to a -12 and add to -2. Well, can we do it? No. So what do we do if quadratic doesn't work, or Box method doesn't work? Use the formula, quadratic formula. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's true.
Thank you.
Let's just keep this in radical form. So 52 could do 4 and 13. Square root of 4 is 2. I get 1 plus and minus radical 13 over 3. Those need to fall between -2 and 2. So if you wanted to confirm that, we could put it in the calculator and get the decimals. 1 plus radical 13 divided by 3 is like a 1.535, so that's in the interval. When you do the minus, you get a negative 0.869, so both of those do fall in our interval. So this time there were 2 places where the derivative would be 0. Alright, is that okay? The next step is the mean value theorem. These are really kind of the same. Rolls is like a special condition of the mean value theorem. So it starts out, mean value theorem has fewer conditions. It has to be continuous on the closed interval, differentiable on the open. Then it tells us that somewhere in the interval, the derivative is equal to f of b minus f of a over b minus a. That's just how you find the slope between the endpoints. Change in y over change in x, you know, your 2 points are a, f of a, and b, f of b. If I told you to find the slope between those, you subtract your y's over, you subtract your x's. So mean value theorem tells us somewhere the derivative equals the slope between the endpoints. Now Rolle's theorem is kind of the same thing, because it said that the 2 points had to have the same y value. What's the slope between those two then? 0. If you drew a line between them, it's just a horizontal line, so in this case the slope is 0, so we were setting the derivative equal to 0. So Rolle's theorem is just one case of the mean value theorem, but it really works for anything. Somewhere the derivative equals the slope between the endpoints. So that's just a few visual examples. Here's your endpoints, the line connecting them. It's like saying the tangent line is parallel to that at some point. So you could find that point. Those lines have the same slope. This time it actually happened twice, that they would have the same slope. So let's look at, and start with a graph first. And I apologize, I know these did not print very well. So here is our function. We're looking on the interval from 2 to 4. Okay, so if I wanted to find the slope of the endpoints, okay, we could get an actual numerical measure for that. All I want you to do is to draw the line that would be parallel to it. So if you think about it, there is, hopefully you guys can use a piece of paper or something and draw a straighter line than I just did. Here's the line between them. So I want to know where the derivative would equal the slope of that line. And so it's approximately at x equals 3. If you drew the tangent line right there, you know the tangent line just hits your graph at that point, and those would be approximately parallel right there. That's what it's saying. Second one, I'm looking between -1 and 3. So when my x is -1, we're down here. 3 are right here. So if I drew the line connecting those, then it tells me that somewhere my derivative would have the same value. So somewhere I'd be able to draw a horizontal tangent line. Where does that one look like? It would be about parallel. When x is 1, right here. If you drew that tangent line, the line just hitting the curve at that point, it would be about the same. Assuming you can draw straighter lines. Okay, so all I did is just draw the line between the endpoints, and I'm trying to draw where the tangent line is parallel. On this one, I want to look between 1 and 4. So here are those points. If I drew the tangent line between them, it's right there. Is there anywhere I would have a tangent line that's horizontal to that? Why? What about like here? Why not? The derivative does not exist right there because it's a sharp corner. So the number of tangents that work between 1 and 4? None, because my original function isn't differentiable when your x is 2, and 2 fell in the interval. So over here, if I said between 0 and 2, okay, so that would just be a horizontal line connecting those. How many times would my tangent be the same? Is there anywhere between 0 and 2 where I would have a horizontal tangent line? No. Because there's a break in the graph there. It's not differentiable at 1. And so it's not breaking the rule because the rule doesn't apply here. If your function isn't differentiable, also it's not continuous. That's really even the first rule. So it broke both of them. Okay, so those are some visual examples to kind of show us what we're doing. Let's do one from an equation then, and show you how that works. So I want to find the value that would make the mean value theorem work here. Mean value theorem has two conditions. It has to be continuous and differentiable. Is this function continuous and differentiable? Yes. Why? It's a polynomial. Again, I'm writing these out so you can look back in your notes and see that I checked both of them. You don't necessarily have to write it out in this much detail, but you do have to state that it is continuous and differentiable because it's a polynomial. Then the mean value theorem says that somewhere the derivative is equal to the slope between the endpoints. So let's find the slope between the endpoints. If I plug in a 0, what do we get out? We plug in a 2. Okay, 8 minus 2, which is 4. So if I find the slope between these things.
6.
Yep. Thank you. So our slope, y2 minus y1 over x2 minus x1. The slope between those things is 3. That means somewhere the derivative has to equal 3. So if we do the derivative, we get 3x squared minus 1. So that equal to 3. So if I add over my 1, divide by 3, square root, plus and minus, 2 over radical 3, except can we leave it like that? So it becomes 2 radical 3 over 3. Would I need both of those? What was my interval? 0 to 2. I said find the C value, it's just the value of x. We would only need the positive because we're only looking between 0 and 2. So it's not that the calculations are all that hard here, but you have to remember your conditions, so make sure you're checking them every time. In terms of our velocities, Rolle's theorem told us that there was somewhere where the velocity was going to be 0. What the mean value theorem tells us is that the instantaneous rate of change, so that's at a particular point in time, is equal to the average rate of change somewhere. So in other words, this kind of makes a little more sense to us. If you drive for 2 hours and travel 120 miles, would you believe that somewhere in your trip you had to hit 60 miles per hour for your speed? Yeah, it would be impossible to have never hit that speed. So that's what it's telling us. Okay, that's at least one instant on that trip, your instantaneous rate of change would equal the average. Let's go ahead and finish this. We don't have much left. Okay. Suppose f of 0 equals -3, and the derivative is always less than or equal to 5 for all values of x. How large can f of 2 finally possibly be? Okay. So let's assume that this is continuous and differentiable, this function, otherwise none of our stuff would work. We know by the mean value theorem, you should just do MVT, mean value theorem, the derivative has to equal the slope between these endpoints, right? So your points are like 0, -3, and 2, whatever this f of 2 is. So if we found that slope, somewhere it'll equal the derivative of this function. Okay, so that tells us your derivative equals f of 2 plus 3 over 2. But what's the biggest this value could be? 5. So if I'm trying to figure out the largest my f of 2 could be, would you agree I just need to pick my largest f of c? So this is, if you're looking back at your notes while we're doing it, f prime of c has to be less than or equal to 5. So if I plugged in a 5, multiply over your 2, subtract your 3, so the largest value for f of 2 is 7. A couple conditions that go along with this. If the derivative is always 0, so if it's 0 everywhere, the only way that would happen is if the original function was a constant. We saw a picture right after the Rolle's theorem, I think the first picture I just showed you, a horizontal line. So if its derivative is 0 everywhere, it has to be a constant. If two functions have the same derivative, then they have to be the same except for possibly a constant value. Remember, if I said like f of x equals these things would have the same derivative, because when you do the derivative of a constant, it's 0. So just note that if the derivatives are equal, that doesn't mean the original functions were equal. It just means that the only difference was that constant value. Okay. One more mean value theorem problem. Determine if the mean value theorem can be applied, and if so, find the value that works. So in order to use the mean value theorem, it has to be continuous and differentiable. First of all, this is a fraction, so it's definitely not continuous everywhere. Okay. Where is this not continuous? -2, because that makes the bottom 0. Is that an issue here? No, because -2 isn't in the interval. So my first condition, it works. It is continuous on -1 to 3. Okay, it's a fraction, so it's definitely not differentiable everywhere. If you wanted to double check, how could you figure out where it is differentiable? Could we do the derivative and look at it? So that's low d high, derivative over top is -2x, minus high d low, derivative over bottom is 3, over low squared. Okay, so I would have a -6x squared and a positive 3x squared. Not in completely lowest terms, but this will work. Where is this not differentiable at? That's what makes the bottom 0. So again, we are okay for the interval we needed. And we only have to be differentiable on the open interval, although more is certainly fine. So then we can do the mean value theorem, which tells us this derivative that we just calculated has to equal the slope between the endpoints. So we were looking at -1 to 3. So if you put a -1 into the original, the opposite of -1 squared, so -1, -3 plus 6, we get a -1/3. We plug a 3 into the original, we get -9 over 9 plus 6, 15, so a -3/5. Have I lost anybody? What do I need to do now? Slope. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. slope is negative 1 over 15. So we can take this derivative that we just calculated. Set it equal to negative 1 over 15. Gave you a pretty ugly one here. How would I go about solving this? Cross multiply. Okay, so this way would give me a negative 45x squared minus 180x. If I do this way, can I FOIL this out and run my negative through at the same time? So if we FOIL this, we'd have an 9x squared minus 36x minus 36. Have I lost anyone? It's quadratic, so what do we set it equal to? 0. So I want my x squared to be positive. I'm going to bring it all over to the right. So if I add over my 45x, add over my 180, I think we could divide all that by 36. 144 divided by 36 is 4. Okay, try box method. Is it going to work? So what do? Quadratic formula. The problem that never ends. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So I get 16 plus 4, so that's a 20. I break it into a 4 and a 5. So there gives me negative 2 plus and minus radical 5. Are both of those in our interval? So get a decimal approximation to check. Negative 2 plus the square root of 5 is like a 0.236, so that's okay. Negative 2 minus the square root of 5 is a negative 4, and that one is not. So just for the interval we needed, I said find the c, so find the value that works. So it was just negative 2 plus radical 5. That is the one point between negative 1 and 3 where the tangent line is equal to, or the slope of the tangent line is equal to the slope between the endpoints. Okay. Questions? We are not going to do the book problems. I have changed my mind. I have a handout. It is going to be due on Tuesday. Monday, I will give you class time to work on it, and then we'll also do a little bit of review because I want to do a quiz on Tuesday as well. So Monday is some review and then a work day for this handout.